In this video, we are going to tackle EtherChannel. EtherChannel is one of those unique types of configuration and options that help you optimize your link usability, and it actually kind of fools or quote-unquote lies the spanning tree. Now what it does is it creates logical links made up of several similar physical links. So what it does is it will be viewed as one logical link to spanning tree protocol. Provides more bandwidth, load balancing, and redundancy, and it's supported on both layer 2 and layer 3 connectivity types. Now, one of the interesting things about EtherChannel that is pretty cool in the fact that what it does is it allows you to identify the ports to use on each switch. So you go in here and you specify the ports that you want to be in an EtherChannel, you configure them as such, and what you're actually doing is you're taking a bunch of what would normally be a individual port to the switch, and now you're, from a software perspective, you're putting these links together so that you can better utilize the flexibility of the additional bandwidth, the additional interfaces, and things like that. So one of the major issues that people have with spanning tree protocol, as you've already seen, is blocked ports, right? That could be a killer in your network. And I know from just personal experience of seeing, inside the data center where, you've got, if you're spending a lot of money on high-speed links, like say a 40 gigabit connection between two switches or something like that, you're not going to want to have a port that is shut down or blocking because you paid a lot of money for that port. You want to have that thing forwarding as much as possible. Well, spanning tree is going to, regardless of the link speed or how much you paid for it, it's going to block that port. As long as there's the potential for a layer 2 loop, that port is going to get blocked. So to mitigate that capability, you are simply going to go in here and you're going to basically tell spanning tree, you know what? There's only one link, not two. So from a spanning tree perspective, it's going to block that link. Now, if you are building your environment in the design model of triangles and not squares, it's going to be less likely for you to have blocked ports or to have a blocked port that's going to go to a less preferred position or place or direction. So in the grand scheme of things, it's one of those things where as long as you design it correctly in triangles and not squares, you'll be in much better shape. Now configuring the EtherChannel is actually really, really simple. You simply would go to you configure a channel group number, and then you specify the mode and set the protocol. Now you would type in channel protocol and then you specify LACP or PAGP. And then what you would do is you type in port channel or channel group 1, and then from there you would simply specify the number, and the number is unique to the switch itself. So it doesn't have to match, but typically you're going to match. You're going to be doing switch 1 and switch 2. Typically I like to use channel group 12. If you're going to be doing switch 1 and switch 3, it's going to be channel group 13. So you would know that switch 1 and switch 3 are grouped together on these two links in that particular channel group. And then from there, you simply go to the interfaces and apply them to you'd say channel group 13, and then go from there. And that's pretty much all you would do. Now there's three different ways of setting up the protocol. You can do auto undesirable, which is PAGP, or you can do active passive, which is LACP. Now the difference between these two is auto and passive are basically saying, I don't really care. I want you to tell me what to do. So basically that's the client aspect of that negotiation, where desirable and active are the server side, saying, okay, this is what we're going to do. We're going to come in here, we're going to run as PAGP, we're going to run as LACP, we're going to run either one of those. Now, if you choose on, that will also work as well. Now, on will work, and I'm not going to get into all of the different combinations that you could do, but I have tested out on hardware platforms of the 3550, the 3750, things like that, where on and auto work, on and desirable work, on and active, on and passive, all those combinations worked. I'm not sure if they will work in viral. I haven't tested those out, but not to complicate the things or the setup, we're going to do a basic implementation. We're going to do LACP with active and passive on one link. We're going to do PAGP on another link. That's going to be auto and desirable. We're going to do one where it's on and one where we're going to be doing either a desirable or on both ends or an active on both ends, just to see the differences of setup. Now, one of the things that's very important to understand here is when you're setting this stuff up, EtherChannels they're exclusive to the they are completely independent. That's the term I was looking. They're independent of access or trunk. Now, what does that mean? That means that EtherChannel does not care whether the port is an access port or if the port is a trunk port. It could be either one. The main thing, the hugely important thing that needs to be in place is you need to absolutely make sure that if you're going to be having two ports that are going to be accessed, that both ports need to be configured as access ports. The same thing goes with trunk links. If you're going to be doing trunk links, both ports or whatever amount of ports, and typically Cisco recommends you do in port groups of 2. I've only done it in 2 because the algorithms that they use and what they call the tuple, T-U-P-L-E, the tuple works much better in even numbered ports. When you start going into 3, 5, 7, or odd numbered port groupings, then you start running into some interesting situations. At the end of the day, it really depends on how you want to go about doing it, but that's typically where I usually see issues come up is when they had odd numbered ports in there. And it gets more involved when you have the more tuples. So tuple is going to be things like your source and destination, MAC address, source and destination, IP address. Are you going to be taking a look at other factors like the port number, things like that? One of the major other things that needs to be configured is you need to make sure the speed and duplex matches. So if the speed and duplex do not match, where you're on and auto or you got gigabit on one end, 100 mega on the other, that could potentially cause some issues. And verifying connectivity. Now, a couple of other things that need to be in place, and we have some guidelines for you guys just so you're aware of it. So when you're dealing with port channel configuration, the port channel interface configuration changes affect the ether channel. So that's going to be the individual interfaces. So if I go to interface port channel 12, for instance, and I go in there and I say switch port mode access, and they were originally configured for trunks, that's going to change them over to trunks. The physical configuration changes affect only the interfaces. So if you go to the interface level and you say, you shut down the port, that's not going to shut down the port channel. That's only going to shut down the member port. Some of the things that have to be the same is same speed and duplex, same mode, access or trunk, same native and allowed VLANs on trunk links, and same access VLAN on access ports. So as long as you have that under control, you're in really good shape. And then you configure these inner parameters on the port channel interface itself. So what we're going to do now is we're going to take a look at going in here to the layer 2 setup here. And what we're going to do is we're going to set up, and we go ahead and draw up like a mini lab, and you guys can follow along at home. And so what you're going to do is you're going to do port channel 12 here. We're going to do 13 here. We're going to do 24 here. My pen is not behaving right now. And we'll do 34 here. There we go. So what we're going to do is this guy's going to be LACP. This guy is going to be PAGP. This guy will be on. And this guy will be LACP as such. And we're going to go ahead and do that. So the configuration is actually really simple. So we're going to go ahead and pull up secure CRT and get that kicked off. So I was going to go ahead and bring this guy down. And we're going to start up here on switch 1 and switch 2. And go from there. So on switch 1, we're going to come in here. We're going to do a show interface trunk. Now we have all our trunks, and the irony of the fact. Okay. I forgot about that. I already done that before just to test some things out. So what I'll do is I'll walk you through the syntax and show you guys what this does. So what we're going to do is we're going to go to global config and we're going to type in interface range gig 1/1 through 2. And what we're going to do here is we're going to type in the channel protocol is going to be LACP. And then what you do now is you exit out of here. I'm sorry, you type in the channel group will be 12, and we're going to say the mode will be, and on this side, so on the switch 1 side, we'll say it's going to be active, and then we'll do that. And then on the switch 2 side, show interface trunk. We're going to go to global config. I forgot that I had done this already, so that's my mistake. I can actually turn that off. We'll type in interface range gig 1/1 through 2. We'll type in the channel protocol is going to be LACP, and the channel group will be 12, and the mode will be passive. Okay, so that's what that does. Now, at this point in time, you would see some things popping up. So what I'm actually going to do is I'm going to move, let me go ahead and say do show IP interface brief. Let me go ahead and do this. I'm going to break the law a little bit here, and I'm going to do what they call a default interface range gig 1/1 through 2. What that's going to do is it's going to bring those two ports back to the default configuration. So if you have a bunch of, let's say, I actually did this for a customer last week actually, and instead of blowing away all of their TACX configuration, SNMP, and a whole bunch of other stuff that was not specific to the interface configuration, I just went into their, I think they had like a 4 or 5 switch stack, and they wanted to repurpose that to another location with that wasn't as prioritized. So they had some older 3750s that they wanted to deploy, and they had just gotten brand new 3850 X's in that were all 48 port PoE switches that were faster. Their old 3750s were 100 meg ports. So we ended up, I just went into the interface range and I just did a default. It took about a minute for everything to flip over, and then it basically brought all the interfaces back to the default configuration. So to do this, we're going to type in interface range gig 1/1 through 2. We're going to, in here, we need to type in the exact same configuration options here. So we typed in do show interface trunk. You're going to see that we're allowed and we're negotiating. Actually, hang on a second. Let me do a. Oh, 24 is still up. So that's why it's showing it, because I have switch 2 to switch 4. The way this is going to work, and on switch 1, you'll see that it says that the that the ether channel bond G1 and 1 and 2 are suspended. LACP not currently enabled on the remote port. So that's okay though. It's just it's a keep alive going back and forth. Basically, if you didn't know this, this is actually it's a syslog that's generated via CDP. But normally, if you see CDP outputs, it's going to say CDP. This is actually an ether channel specific one. So we go back over to switch 2. We're going to type in here, and on the switch 1 side, you'll see that these ports are on this side. You'll see on these here that they're negotiating. They're negotiating .1Q because they're set to auto. So we're going to type in the switch port trunk encapsulation is .1Q. Switch port mode is trunk. And then what we're going to do from here, we're going to type in the do show interface trunk. And now the ports are configured as the 802.1Q trunks, which is good. We're going to then say the channel protocol is LACP, and that the channel group 12 is mode we'll say passive. I'm not sure what the other side is set to. So we'll say do show run interface gig 1/1 active. Okay. And that's where I looked right there. So we're going to say switch 2, we're going to say is passive, we're going to hit the enter key, and then you're going to see some things pop up now. He should negotiate a port channel, and he does. So it'll take just a couple seconds for that to happen. This side, he's do show IP interface brief, do show ether channel summary. Okay, they are I'm getting a S for lowercase s in both of these guys. So S means that these guys are suspended. So what's up here? Do show IP interface brief. Oh, they are reset to down. Do show run interface gig 1/1. Okay, they're both set up the same. Let me shut them off and see if that'll trigger it. And then do a no shut. I'm waiting for the port channel 2 to go down, or 12 to go down. Do a do show IP interface brief. Okay, it's down, so we're going to type in no shut, bring them back up. Because what we're going to do is we're going to be trying to renegotiate here and see if this actually will bring them back up. LACP currently not enabled on the remote port. So is this guy not trying to actively do it? Oh, I did it on the wrong side, that's why. Do show IP interface brief. We're going to say shut. So bring them down. So I shut no shut on the wrong end. At least I think that's what I did wrong. We'll type in no shut, bring them back up. See if we can't see if we can renegotiate here. There we go. That's what we wanted to see. So balancing the ports definitely does help. But actually, what we ran into at that point was what they call an order of operations issue. So we type in do show IP interface brief. That port is back up. If we type in do show EtherChannel summary, you'll see that we're aggregated right there. PP, capital P, means that they are port channel and bundled. And SU right here, this access code, that means that they are layer 2 and it's in use, which is good. So we type in do show interface trunk, that they are operational. So that's basically how you would do that. And so you would just repeat the process over and over and over again, and then see port channel 12 is back up. So then on the connection between, for PAGP, you would just do the same thing. You would type in interface range gig 1/3 and gig 2/0. Channel group is going to be PAGP. I'm sorry, channel protocol is PAGP. The command rejected is already part of a channel with a different type of protocol enabled. So let's say here, do show run interface gig 1/3. Oh, LACP. Okay, I have LACP running there. So again, it's one of those things where it's just a matter of making sure that the configuration is the equal on both sides. Now, one of the cool things here is if we jump out of here and do a show spanning tree, you're going to see that the only things that are considered to be for port channel 13, the cost goes down to 3 because of the fact that when you take two 1 gigabit connections, that actually equals 2 gigabits. So therefore, it's going to be faster than the other ones. So what we can do here is we can go up to here and go to interface port channel 13 and type in the spanning tree link type is going to be point-to-point. Now, I don't think there's any other options beyond that. We do have the option of shared, and that's fine. But type in do show spanning tree, you're going to see that these guys are, and that one is point-to-point. Not that it would make much of a difference, but if we do 12 and do the same thing, it'll be point-to-point as well there. Now, what I would normally do here is on, let's say, interface gig 0/3, I would type in a spanning tree port type or port fast, and I would type in edge. What's actually interesting about this is, if we go back to port fast, Cisco is moving their newer code, the latest and greatest code. So anything when you get things like the 3650, the 3850, stuff like that, those platforms are going to be running iOS XE. And what they're doing on the newer and newer code, if we do a do show version pipe include iOS, you're going to see that we're running on newer and newer code. We're on 15.2.4 here. What you'll find is they're trying to make sure that the syntax on iOS XE and NXOS for the Nexus platform is relatively close. So that here I am, I'm an iOS engineer. I'm learning more and more about iOS XR as I dig deeper and deeper into the technologies on CCNP and CCIe technologies. And they're trying to make the configuration more and more specific to so that if I, for some reason have to jump on a Nexus 7000 switch, I can be able to say, okay, spanning tree port fast is going to be edge. So I would type in spanning tree port fast is edge, and I could say hit the enter key. And now before in older versions of iOS, I would just type in spanning tree port fast. So if I was to telnet to my home switch here, I'm going to go ahead and just grab this guy real quick and give you an example of a non-viral switch. So 10.255.1. I think 54 on 23. Yep, and go ahead and bring this guy over. I'll type in Rob and the password. And if I was to do a show IP, show interface status, for instance, do a show, I haven't actually named anything, but if I was to go to say fast Ethernet 0/2, let's actually do a show MAC address table for VLAN 1. I can come down here and I could say, let's see here. There's a bunch of them in there. 2. I believe that I am on port 2, if I'm not mistaken. If I do a ipconfig /all, and I bring this guy back up to the top, I am, is that 88? I can't read that, it's too small for me. BB, B8, B8, is there a B8? Yeah, right here. This is my MAC address right here. So that means right there, if I was to go to global config and type in interface, say fast 0/2, and type in spanning tree port type, or port fast, you wouldn't have the ability to do edge. So I would do that, and then it would automatically do that for me. So I think if I do show spanning tree, I'm already running I'm running IEEE. So I only have one switch, so it doesn't make much of a difference. Why does it look like that? That's really amazing. 10, what does 10 connect to? Show CDP neighbors. Port 10 is my root port. Interesting. I'm scratching my head because I'm trying to think of what that one would be. But I already have point-to-point edge here, so that works out just fine. So we're going to go ahead and just close that one out, just to give you guys an example of what that would look like. So on the newer syntax, it's edge, where they're trying to make it more Nexus and iOS similarities. So that's just going to be an example of how you could optimize the setup here. So we already have the port channels configured, and as you can see, the syntax is actually really simple. As long as you follow that along, you should be fine. So beyond that, that's how you would basically lie to spanning tree. Now, what you'll find about this setup is you're not specifically going to be in this situation here. We have a bunch of squares. So let me go ahead and explain what I mean by that. So here we have, you have a square. You have a square drawn. Normally you wouldn't do this. Normally you would have, let's say, switch 1 and switch 2. They would be connected to each other like this. And then what you would do is this would be, say, your distribution layer, like we talked about at the very beginning in IP fundamentals. And normally you would have this connect down here and this guy connect down here to an access layer switch. And the same thing would be over here and over here would be an access layer switch. So this would be access. This would be access. Now by doing this here, this is what they call triangles, because you have a triangle here. So you'd have D1 to D and D2, and then A1 and A2. So you'd have a uplink this way, an uplink this way, and a bidirectional link this way. And you'd be doing, that would be your one triangle. You'd have another triangle on the other side. So this guy here, this way here, here, and here. You'd have your triangle set up that way. So if A1 lost the connection to D1, you would still be able to go through D2 to get to wherever it needs to go. By having, and then in this case here, typically you would simply say that this link here would be the less preferred path, or what you could do, and in most modern networks, is the distribution switches would actually be stackwise or VSS or VPC together. So they would actually look like one logical switch instead of two physical switches like they're drawn out here. So instead of it looking like D1 and D2 are two different switches, it would actually be like this. You'd have D1 and 2 connect down to, and there'd be two individual connections, A1 and then A2 would connect to each other to D1 and D2. So it would actually look like this. So there'd actually be two links coming up, one to D1, the other one would be going to D2. This guy would have a connection going from D1 to D and D2 as well. And then they would just be bundled like that. So this would actually look like this as you're moving forward. That'd be the ideal situation. So if D1 died, you'd have D2 would still be available. You'd just have two fiber uplinks of, say 10 gigabits per second or something like that, and go forward with that. That's the typical design that I deploy, and it does scale quite well, because then what you can do is you can have like a couple of, the most common thing I do is I'll do 4 distribution switches like this. I'll stack 4 of them together, and then I will have at the edge in like a closet, I'll have, and this scales really, really well because of the fact of the way you build it out, is I would dedicate, I'd span it out to where I would do, say, you'd have all these different access layer switches in these closets, and each one would connect to the distribution block. And they'd all connect up this way, and they'd all have connectivity here. They'd all have, like I would do the odd, so this was going to be switch 1, this would be switch 2, this would be switch 3, 4, etc. I would go to the individual slot numbers, and I would make sure that they're all interconnected. So in case, switch 1 would connect to slots 1 and 3. And this 2 would connect to 2 and 4. Switch 3 would connect to slots 1 and 3. So I would keep the odd with the odd, the even with the even. So in case a slot number decided to, check out and not want to work anymore, I'd be able to just swap that out, and it would the port channeling would come right back up. So gives you a lot of flexibility in that regard, which this kind of architecture here would simply be what they call a leaf spine leaf, to where you'd have your leaf here, you have your spine here going down to a leaf, so that none of your access layer switches right here, these two right here, they wouldn't be able to talk to each other without having to go through the distribution switches. So this would be a aggregation point as you're going forward. So that would give you a lot of flexibility in that regard, and then you could scale. So that you could theoretically add another distribution block here and add a bunch of other switches, across the top here, and then connect them, and these two would be able to talk with each other. So you could you could grow your network out pretty much to whatever level you want to, and never have a latency issue, theoretically speaking. You would never have issues with redundancy because of the fact that you'd only have 2 hops to every location in the network. Gives you a lot of flexibility. That's actually the more common in data centers, and as a matter of fact, the service provider that I work for, that is actually the design we're moving towards. And we're not quite there yet with that. We have a slightly different architecture in place, but that gives us the flexibility of, if a core device goes down, because they're all stacked together, and I think we're at 3850s now. I think we're going to 4500Es and Nexus. I think we're going to the 7Ks or 9Ks, one of the two. But we're going to go really, really high end because of the fact that we're a service provider. We absolutely have to have SLAs in place and equipment that's going to support those SLAs for our customers. That's the important factor right there. Sorry to go down the rabbit hole design, but it actually played very well into the EtherChannel video, so that's why I decided to throw it in there.